Just a quick overview of what we're going to go through. I'm going to give you a quick plans overview just to kind of give you some information on the plans you're seeing and the exports that are available. A quick sneak peek of what's to come for next year. Ray is going to cover the bulk exports, the GPX tracks, CSV, map image export, Google Earth, the AT5 map chart, and the side scan mosaic export. And then we're going to finish off with Ian, who's going to cover the shapefile exports. And then feel free to answer or ask any questions in the chat. We'll have the Q&A up or the chat. I'll be looking at that once Ray and Ian take over, keeping you guys updated and answering as many questions as possible. If you want, you can save your question toward the end, and we might have a few minutes left over to answer some questions as well. So I wanted to touch base on the plans that we have and what you're going to see today. Every export option you see today is going to be covered in the Habitat Plus and the Habitat Plus single water body. The basic subscription, you're only going to get the depth layer CSV and the AT5 map chart. And then the habitat layer, you're going to get depth, bottom hardness, vegetation biovolume, CSV point, and grid exports, as well as the AT5 map chart. That habitat plan is really designed for organizations or individuals with strong GIS skills because it gives you all of that data that you need to put into your own platform. But if you're looking for the easy button and you're looking for all the exports you see today, the Habitat Plus plan with a single water body Habitat Plus is going to be your go-to option. And then just to add on, the EcoFish does include all the exports related to the fish layer. So if you do add that onto another layer, subscription, you will get all those exports for that as well. So just a quick update of what's coming in 2026. One of the first things that you'll probably see is our hypsographic curve. So now after every trip in the Habitat Plus level on the report, you'll see the hypsographic data. It's going to be automatically generated based on your trip and will be in that automated report that you can see when you click view report or download report. So that way there's no more exporting into Excel and doing the hypsographic curve on your own. We'll take care of that for you. The big one that's coming in the beginning of 2026 is our new transect design tool. So you'll be able to draw your transects on a lake that you're planning on mapping and then import them into your unit, as you can see here. This is going to be like another add-on or a standalone tool. So if you don't have a BioBase account or if you don't have a Lorentz or Simrad, you could still use the transect design tool, pull them in to record and do your own transects that way. And then, you know, whether you're new to GIS or you're deep into GIS every day, you know, BioBase meets you where you are. You know, we have a full solution for those non-GIS users, and then powerful companion for those GIS experts, you know, that are just looking to unlock more value, insight, and efficiency, you know, from the tools that you're already using. So, you know, we try to make things as easy as possible and as powerful as possible, no matter what skill level you are. You know, BioBase is a great processing engine. And for that, are you guys ready to drink from the fire hose? This is Ray's favorite saying, and I figured I'd surprise this for him with him taking over. All right, Ray.
All right, great. Yes, I love this. Yeah, thanks again for joining. And what I'm gonna do is I don't have this timed, but we'll just kind of fly by the seat of our pants here, and we'll see how things go. But what I'm gonna do is actually walk you through an actual merge that I have in my test account, and then walk through how to like process all the outputs. Just want to make sure. And I also have a display, Lorentz display, and I'm going to take you through how to import like GPX files, the charts and things like that, so you know which buttons to push. Things will be going pretty quickly. So again, that's why it's good that we're recording this, so you can always just go back and review when there's a specific thing that is of interest to you. All right, so without further ado, I'll go ahead and share my screen here. Okay, so there is the example of the display. And here first. Okay. So first we'll start here. We'll clear the search here. I was looking for a good side scan trip. And so what we're going to look at is we're going to do everything. This is one of our favorite test lakes, Orchard Lake. And this is the example of the BioBase dashboard here. We're going to go into our merge. Here's all the raw sonar files that were merged. Actually, before we dig in, I'll tell you about the bulk export feature. The bulk export feature is it downloads the major exports that that you might want to use in a bulk way for the entire water body. And but it's not every export. It's just point and grid CSV files, KMZ, KML, and the automated report. When you click this, it issues a request. It goes to our servers, collects all the data, zips it up, puts it in temporary storage that's there for 30 days. When you'll get an email saying it's done processing, maybe about 30 minutes later or so, and then this link will be active, or that email, you can just click on the link in the email, and then you can, for the next 30 days, you can go fetch those data. So here's an example. It's all zipped up, and here's all the trips that are available for that, all the merges that you have available. And you can see here's all that data. So that's one export. So go back to our example here. So let's now go into the merge. And let's see here. All right. So here's the depth layer, and here's where you can find all the other layers. But what I'm going to do is I'm going to walk you through all the exports that are listed here, and then I'm also going to jump over to show you how to export a Polygon, and also create and export waypoints. All right. And then at the end, I will pass it over to Ian to show you how to export the shape files. All right, so first on the list, we have export GPX tracks. When we talk about that, we're talking about these tracks, your back and forth passes. This feature is going to be really handy when, let's say, you want to do a repeat survey and you want to go over, and it's really important when you're doing repeat surveys to follow the same path you did before. And so this feature allows you to do that. So we're going to export data, export GPX tracks, and we have a feature coming out that we're going to automatically have highlighted the tracks in this trip. We don't have that yet, so I have to do my Control F, and I know it's they're from 2013, and here we go. They're down here. So we check all of these. So like I said, we're going to get a feature that's going to have those automatically checked. We hit submit, and then that's going to download those tracks. All right, so now I have all this stuff kind of queued up, so you're not watching me go in between, the SD card and whatnot, but I'm going to want to put this on my SD card and then put this into the unit. And so here is an example here. I'm going to go to the page button, and I'm going to go to storage. So imagine I took that GPX file, put it on the SD card, put it back in the unit, and here it is, Orchard Tracks. It's this guy right here. So you're going to go to storage, and now we're going to import. Hit yes. Okay. Close. Actually, I want to go back because I want to show you where we are. So we had that. Now we got that imported. The tracks, if you want to see the tracks, it's buried in this waypoint area. So you see waypoints, routes, trails. So we hit trails. Here's where all those trails are. So now we can just pick any one of these and just go to and just highlight it and then just go to show. Oops, and we're gonna go to, oh, there it is, yeah. Zoom in, and there is all the tracks. So now you can try to follow those in the repeat survey. All right, so that is the export tracks feature. Okay. All right, CSV data. We have both grid and point. I'll tell a little bit about both, and I'm going to bring it into GIS. And the QGIS, which is a free open source GIS, really, it's a very, bring it into GIS, it's a really powerful exploratory data analysis tool, and other just kind of looking at multiple layers from other kinds of data sets. So we're going to start though with point. You hit submit. It downloads a file that lists all the points along your track and information about the location, the start and end time, and then the sonar channel, the your miles per whatever units you're using to track speed, water temperature, your offsets, if there's a tidal offset, depth to bottom, that is the depth, it's self-explanatory, depth to plant, and then you can take those two to get your plant height, your bio volume, and then your bottom hardness. Now, the example I'm going to show here, if we go back to our map, this lake has a lot of aquatic vegetation, and I'm going to use the example of bottom hardness to show you some exploratory data analysis you can do with the bottom hardness feature. So let's just take the track off, and we're going to do, we're going to turn on the bottom hardness layer here. So here you can see this is this full, bottom hardness map, but I want to dig in deeper. There's when you have a dense aquatic vegetation growing, we cleanse out any bottom hardness values that are in vegetation of 25% biovolume or greater, because we don't know how hard the bottom is. So there is underlying data here that is going to be probably missing because of that data cleansing, because there's a lot of vegetation in this lake. And so what I did here is I did a sort by the hardness NA. That means there's no values there. So, and then I deleted that out. And now we're going to display this in QGIS. So this is the layer that I brought in, and you bring in that layer, and you specify the projection. All of our exports, the projection is in WGS 84, and that's what's listed here. And you can project it into any local projection that you want. So anyway, but what this does is this shows now all of the points of where where the bottom hardness was collected. And now you can see that there are gaps where, the vegetation was growing. And so this is just a good exploratory data analysis tool to kind of know when we look at now, if we bring in the grid data, oops, this is the grid data. Oh, that is the vegetation grid. I guess I don't have the hardness grid in here. But again, if we look at this map, you can see how the interpolation fills all that stuff in. So it's just an example kind of data exploratory tool. All right, so that's point. Then grid, all that is export CSV data. Grid. The example I got teed up is the vegetation. This is the Kriging interpolation grid data. So there's that downloaded, and then when I added that to QGIS, this is what that looked like. And all I did here, and actually here, let's get this projected into so it's kind of looking like kind of stretched, and I want to get the view, make it look a little more real. So we're gonna go hit OK. Yeah. Get out of here. All right. So now this looks more like what looks like in BioBase. And all I did here was just did a different coloring of BioVolume here with the QGIS color ramps. So just kind of a cool tool, but this is just the points. And what you can do then is you can convert this to raster if you wanted to do some more spatial analysis, or get it into a, you can do a lot more with grids than you can with vector data. So that's the CSV export. All right. And if any questions come up, Ryan, I can't recall if you mentioned that there's the Q&A section. Ryan and Ian will be answering Q&A. Ryan, did you mention that?
Yep. And
Okay,
there's the
cool.
Q&A and the chat, so they could go either
Yep.
place.
Awesome. Cool. All right. So I am going through this fast. All right. So next, we're going to skip map export image. All that is just if you want to get a nice screenshot with the scale bar and things like that and the legend, you can use that feature, but that's pretty self-explanatory. Okay, so now we'll go to Google Earth. A couple things to mention about this. There is two options, KMZ and KML. What KMZ does, they're bigger files, but they, when you export KMZ, it will actually export the a local copy of the image. And whereas KML just references the images on our server. So a lot lighter. KML is a lot lighter. They both function, to the end user, they won't notice a difference. But if you want an actual hard copy of the image on your own, and again, for your own use, completely offline, that's KMZ. And yeah, and then KML though is just, you just really want a light version. It's KML. So let's just look at, let's see what I got here. Well, let's look at KML for now. Let's export, or actually a couple notes here about what you see with these different arrows, and why does this look different for hardness. This is what this does when you request a KML or KMZ file. It sends the request to our servers. Depending on the lake size and how much data is there, it's going to take some time. It may take some time. Bigger lakes with bigger data sets take longer than, like smaller ponds. But that goes back to processing. It does its stuff, and then it comes back again, and it's just like that bulk export. It's available for 30 days. And then when you click this link, it will download that data. I'll show you an example of the email here. So here's an example of, whether you're downloading KML or KMZ, or downloading, the bulk export. If you did a Polygon, anything that where processing is creating that output, you'll get an email saying, hey, it's all done. You can go here, download the data, and it's there. So let's go back here. We're looking at vegetation. We just click click download, and it goes to our downloads folder. Here it is, the zip file. So zip files, hopefully most of you know how to handle zip files, but you just right click on this and you want to extract all of them. So before you do any analysis, you got to unzip zip files. So we're just going to extract it to downloads folder here. Now look at there, you notice there's all these files, and these are all tiles. It's a tile, tiles of essentially PNG images. So I have Google Earth keyed up here, and we are going to load those files. So we're going to go to open. And this is also a really interesting subtlety that some customers and that we've kind of stumbled on. But one of the things you'll want to note is how your files are sorted in your in Windows Explorer. And you want to make sure that, if I remember this right, I think the T's need to be on the bottom. And just remember that T's need to be on the bottom because, so in other words, you got to sort your layers so they layer right. I'm going to do this. I'm going to do it the backwards way, and you're going to see what the problem is. So I'm going to select all of these files, and I'm going to add them. And then Google Earth will zoom in to where it is in the lake, or where it is in the world. And here is the vegetation map, and it looks great. Looks like a pretty exact. It's like an exact copy. We're going to turn on the vegetation here. Turn off the tracks. So if I toggle back and forth, there you go. There you see the Google Earth export. Now, what I was talking about with the T layers is those are the contours. So if we can uncheck these, and you can see as I uncheck these, you can see that there's contours underneath. Those are the contours. So then what so that's just something that I stumbled on, that we can fix this. If we, let's delete this. We're gonna go to, oops, file, open. Now we're gonna sort it the other way. Try this again, select them all, open. And now they should draw in the right order. There you go. Oh, there's the contours. Now, so there's a couple then ways you could share this with partners. You could just share the zip file. That works. Another way you could do it is just do this save place as, and you can save it as a KMZ. So let's go to this orchard places, put that in the downloads folder. And that will work to share it that way. There you go, orchard places, KMZ, it bundles those all together. You can see it's only 4 kilobytes because again, it's referencing all the images on our servers. So it's really, really light, really easy. You could put that in an email. So that's a great way to share data. All right. So that is Google Earth. Just one more last note about Google Earth. It works best right now with the desktop version. It looks like Google is going, they've now got subscriptions for the web version. So it's somewhat limited with the freemium version of the web application for Google Earth. So I don't know how long that's going to be free. I don't know how long the desktop version is going to be around. So just keep that in mind. But for now, the desktop version works great for handling these files. All right. Now export AT5 charts. Let's for this, let's back up a little bit. We're going to go to our dashboard. And we need to first, well, first here, I want to make sure that this is refreshed and this is still working because I'm going to go back and forth to this. Okay, good. Good. All right. All right. So this is a way you can get your BioBase map back onto your chart plotter, back onto your Lorentz chart. So if you're doing any follow-up surveys on the vegetation survey, if you're doing dredging, and you want to go to a specific area on that map. Whatever you might want to, use that information for. I'm going to show you how to get the BioBase data back onto your Lorentz chart plotter. One other note is this will probably, as Lorentz develops a new operating system, this capability will change. And so for now, and these devices will be out there for quite a while, and we'll be supporting this feature for a while yet. And it's a pretty handy feature. So, but first, what we need to do is you need to register your chart plotter on your dashboard here. I have this, so I call it, this is my test device, Office HDS 7 Live here. Go to view. You're going to need to know the serial number and the content ID. So where do you get that? What is that? So you go to your, we're going to need to go to the settings on the upper left there, the gear wheel. And then we're going to go to our About menu. And what you need to get is the serial number here and content ID. And then you're going to take that information. What that does is that it encrypts the map. So it's just for that device. So it's the reason why it was designed that way is so you would have to have, like, CMAP's permission, or you couldn't basically be a chart reseller outside of CMAP. But we have some capabilities where we can help you out there if you want to share it with a small set of partners. But yeah, so just contact us about that. Okay, so first you got to do that. All right. Okay, so we have that registered. Now we're gonna go back to our dashboard, trips and merges. That was Orchard Lake. Close up some of these guys. Okay. Tools, export data, export AT5 map chart. You can have multiple devices, but I just have one that's registered. You only have one option to export all available layers. So then we're going to hit submit. So that downloads, it's another zip file. Go back to our downloads. All right, close out some of this stuff so it doesn't get too busy. And where is that? Here it is. Just make it easy. We're going to extract it. Extract it right here. All right, so let's see what's inside of this thing. Okay. So here's all the files that you need. You'll need an XML file, a large, medium, and small AT5 file, and this permits file is that's that encryption text file. You also need to have that. So what you can do is rename this to something that makes sense to you. So Orchard, this was actually the data we're looking at was from 2013. And this was, I don't know, it was like July or something. So this is the July 2013 map. And then what you can do is you can take that whole folder and put that on your SD card. Okay. And the system is automatically, the Lowrance is automatically going to recognize that file there. So if I look at, let's see, does it show the folder? Oh yeah, there you go. It shows the folder there. So the chart will automatically recognize it. And I'm going to show you also one thing to also keep in mind. So we're going to clear the cursor for now. So I live in Bayport, Minnesota. And so here's where it would set up by default. It's going to, if you're looking at this in the office or you're out in a different area and you put this D card in, one thing to keep in mind is you'll want to have this centered on the area where the chart is. We know that that Orchard Lake is down in Burnsville, Minnesota, or near there. So we're gonna kind of get it centered around that area, because when we go to chart source, it's gonna list it as a CMap personal map. So we're gonna say yes, select that, okay. And there it will show up. Now notice there's no other chart data. So if you're in some other part of the world, it's not going to know where you are. And you might have a hard time finding where the water body is. So there is the chart. This is the vegetation map. There you can see the BioBase map. And there's there's the vegetation layer. Now, let's just say you didn't want to look at the vegetation layer, you're more interested in the depth or the bottom hardness. That's found in the, it's called chart categories. So we go to, I think, chart options. There it is, categories. And we are going to turn off vegetation. Okay. Then we're going to come back here and it's going to show you then the depth map. And this is the depth map that you created. Now, if we want to look at the bottom hardness, we just check this box. And now there's the bottom hardness, right? And we can go back. Let's see here. Here, I'm just kind of comparing. Here's layers. There you go. There's the bottom hardness, right? So it's an exact representation of that. So that's kind of a neat feature. All right, export data. So that's AT5. All right, so now we're going to jump to polygons. Let's go back to vegetation. And let's just pretend that this was we created a polygon. Let's just pretend that this was a aquatic plant management area. We're going to apply a herbicide here, or here's an invasive species, hypothetically speaking. I know it's kind of hard to see. It's yellow on, it's not a good background color, but if we turn off the, if we go back to the depth, you can maybe see it a little better. So here's that area. And now we want to export. Let's just say hypothetically we're a service provider and we go and map the vegetation, but we're not actually going to be doing the herbicide application. We're going to be there's another applicator that's coming in, but needs to know where to apply. So what you could do is you could export this as a shapefile. And what we're actually going to do is convert the shapefile to GPX. Eventually, we'll probably push out a feature that you could just download it straight as GPX. But for right now, it's you have to download it downloads as a shapefile. So here's an example of that shapefile. We'll go back to our downloads. And again, it's a zip file. So we're going to extract that. Okay. So here's your shapefile. And we could add that to this map. There you go. So we just pull that in if we wanted to do some analysis in GIS. Great. But let's say we wanted to get this as a GPX file, and then so we could import it as a trail into our Lorenz. There's a lot of different third-party softwares that convert shapefile to GPX. But I use this Minnesota DNR GPS extension. It's really old, but it still works, and it works pretty well. And all you do is load the shapefile. Here, who's this guy? Got to make sure you select. It's the 2D shape. Yeah. So you load that shapefile. Yeah, I think we can just, that's fine. We just call it that. It's fine. And then we just save to file. And we want to save that to GPX. Orchard Poly. And put that in the downloads folder here. Save track. And there it is. It should have saved. Orchard Poly. So now you can put that on your SD card. And let's see here. To make this less busy, I'm going to turn all these trails off. So here's where you do that. Okay. Storage. And like I said, I already have this saved. That was this guy. Come on. All right. Import. Okay. And it displayed it automatically. There you go. So that would be an example, right? You could just say that GPX file, you could send that to whatever third-party partner that you're working on. Hey, focus on this area right here. So that's a pretty slick tool for that. Okay, so that is the Polygon. Let's see, where are we? Okay, waypoints. We also had an improvement to the waypoints feature recently. And now we have like these labels, real easy now to get data in, uploaded, exported, downloaded. So just a lot more efficient there. It was kind of clunky on previous to now. But now let's just take this hypothetical situation where there's actually specific beds that you wanted to go do some follow-up sampling. Or let's say, you're looking at the, or let's say you wanted to mark certain areas of interest and you want to return to those areas to follow up, do additional surveying. So this is an example of, I right-clicked here, and we can maybe check another area. Add waypoint. Check 6 here. There you go. And as you can see another feature too, as you zoom out, it kind of declutters, so it's not so crazy in terms of the density of points. So I go through, I create all those waypoints. Now what I want to do is I want to get these waypoints as a GPX file. So then what I do is I just hit download waypoints. Okay, and this is where you can select what waypoints you want to download. I will show you, I do have both of these downloaded. There we go. You can download GPX or CSV. Hit submit. Did it do it? Let's see here. Sure if it did it. Oh, there it is. So there it downloaded. One other thing I want to show you before we look at it in the Lorentz. Let's close this. Let's say you have point intercept vegetation sites that you created and you want to upload those and go from point to point. You can upload those waypoints. You have 2 different ways you can upload those waypoints, as GPX or CSV. So GPX, let's say you have waypoints on your Lorentz. Let's say you marked habitat structures. You dumped habitat structures out on the lake, and now you want to see where those are on the BioBase map. That would be the way, that's where you would export your GPX, export your waypoints as GPX, and then import those into BioBase. Or if you created, let's say, point intercept points, and you want to get those, the point intercept points are either Shapefile and you're able to get it, or it's in CSV, you can import that and then export the GPX. So that's what we did here. So here are point intercept vegetation points. See all those. And we also exported those with that previous action. All right. So now I go to.
Hey Ray, before you go any further, can you pop back to the Polygon tab real quick? Spencer,
Yes.
to answer your question, to create a polygon, you would just click the polygon with the green plus button. You would name it, draw your polygon, and then click save. And then that's you creating the polygon, and then you can follow the exporting steps from there. Thanks, Ray.
Yep. Okay. And we'll just do a little mock thing here. And that's good. We got a little bit, we're doing okay for time. And I'm just adjusting that polygon. Let's say there's a specific area we want to focus on here. Just gonna test. And now we're gonna hit save. Now what this does is, again, it goes back to our servers. It does its thing. As you'll see right now, test, you can see it doesn't have it. doesn't have any of the statistics yet, and that's all shows as zeros until it gets done processing. And then we get the email, or we just refresh our browser, we come back later, and the data will be there, and then you'll be able to export it. So thanks, good question. All right. So now, okay, so there's the waypoints for the point intercept vegetation and the waypoints of like those, what we were going to check. So let's just first start with the point intercept vegetation points. Import. Yes. Close. Good old display. There they are. So now we can just hop from point to point, throw a rake, record that data, and it's all in the system there. Okay. Let's do the other waypoints. Those were here. We can, and if you want, you can always. There's a lot of features with these Lorentz units. Like you can do all kinds of different stuff with changing the changing the icon and stuff. So anyway, so that's how that works. Last, and then I'll leave the last 12 minutes to Ian there. We mentioned, Ryan mentioned side scan mosaic. That's another feature that's, the side scan was not, that's an optional processing feature. It wasn't created in this map. So though I had side scan, it would be listed your side scan mosaic. What that does is it downloads a PNG and a PGW file. PGW is the spatial file for PNG. And those are in the GIS vernacular, they are raster files. I have that here. I have that queued up here. Here's an example of the side scan layer. As we zoom in here, here's an example of that side scan image. There's like a tree growing here, or growing. It's laying on the bottom there. And then you can see the sand ripples. Export data, there's that side scan mosaic. I did load that up into GIS. I loaded it as raster, and we can go zoom in on that. Zoom to layer. There it is. Is it going to show the image? Guess maybe that's why. Let's put this back on WGS 84. Now try it again. Zoom to layer. There we go. So here's that area we were looking at. So now it's in GIS, and you can start looking at that with all the other layers. All right, Ian. I think it's up to you now. I'll stop sharing.
And before Ian starts,
Yeah.
Just a reminder, I threw a poll in the chat here, just asking what your go-to post BioBase software is. This is kind of help us develop features because we want to develop and shape the platform into the direction you guys need. So if you could answer that, that'd be awesome. And then Ian, get started.
Yeah, all right. So let me share my screen. So I wanted to show you guys the Shapefile exports and highlight a couple things that you'll need to know to make sense of and work with the files. So that's done through tools, export shapefiles. I've already downloaded the depth and vegetation files for this example. And I've extracted them and copied them over to my, I'm going to be using ArcGIS for this example. It looks like we have a pretty good amount of Arc users, so that's good. So if I pull in the depth area or the d_area shapefile, you'll see that it looks like just the entire extent of the water body or the entire survey extent. But if we open up the attribute table, we'll notice that there's actually 31 features in this shapefile, or 31 rows. Even though if we go back to the BioBase map, the maximum depth is only 15 feet. And that's because during processing, these are the required features for displaying in BioBase. And so this is just the way that the data comes out. So the columns we want to focus on or look at here are the max elevation and the min elevation. If we sort by max elevation, we'll see that this very top row goes from 0 to 1 foot, or 0.3 meters. This data is displayed in meters. So if I zoom out, you'll see that this feature represents the areas that are 0 to 1 foot deep. If I go down through here, you'll see that it goes from 0 to 2, 0 to 4, all the way to 0 to the maximum maximum depth, or the entire extent of the water body. So you'll notice that there's a lot of overlapping features that we don't need. They're redundant. We need to delete these to get this to display correctly. And the best way to do that is to add a field and call it diff, because we're going to be calculating a difference. Make it a float. And so if we calculate the difference between max elevation and min elevation using, let me clear this, okay. Calculate the difference using calculate field between max elevation and the minimum elevation, we will see the depth range that each of those features represents. And if we sort by diff, we'll see that these top ones represent a range of 1 foot. And these are the ones that we want. So we will select all of the ones that have a difference of 1 foot here. Whoops, one more. There's 16 features. And there's lots of different ways you can do this. You can export this now as another shapefile, or the easiest way is just to switch the selection and delete all the ones that are overlapping the 1 foot intervals. And so now we have no overlapping features, just the features that represent 1 foot depth. And this is a much more workable, usable shapefile. It should make a lot more sense to people that are familiar with these types of files. And so yeah, now we can do anything with this, including this is a specific feature to ArcGIS. Since we have a few users that have access to that program, I'm going to show you a cool little trick here. Symbolize these, symbolize the polygon features, make a nice pretty map. So I'm going to add another field. I'm going to make it a text field. That's important. It needs to be a text field. And then if you'll notice, there's already a column in here titled CLR RGB listed here, this one. So we can actually use these color code, they're hexadecimal color codes. We can use them to symbolize the polygon. But first we need to add a pound sign to the beginning. It's a requirement for ArcGIS to recognize them as hexadecimal color codes. So I'm going to use calculate field again. And I'm going to use this arcade expression to add a pound sign to the beginning of all these values. So click OK. Oops. Sorry, that was the wrong expression. This is the right one. All right, here we go. So now I've automatically added a pound sign to the beginning of all these color code values. And now I can go to symbology. I need to click on various symbology by attribute and check allow symbol property connections. And then go back to the symbology, click on this, it needs to be single symbol, click on the symbol, click on solid fill. And then there's this attribute mapping. So I can actually select that new color code field and automatically display this polygon with the same colors that you see in your BioBase account. So that's a pretty cool, quick and easy way to make nice maps in Arc using this attribute mapping feature in Arc. I also wanted to show you real quick the vegetation layer, because I've had questions about this recently. So I can do the same thing with the attribute mapping. If I add another field, color code, make it text. Here, calculate field. My expression's already there, just hit OK. Symbology, allow symbol property connections, solid fill, and then I'll select my color code column. So the color is filled in, but you'll notice that there's kind of some weirdness happening here. What you're seeing is the actual outline of each feature, and that can be easily removed just by unchecking the solid stroke. Or you could also, symbolize the solid stroke with a more transparent line or a different color line, whatever you like. In most cases, it makes sense just to remove it, and then you can, to make it extra pretty, you can even add the contour lines on top and symbolize that and label that the way you'd like. So yes, a couple really cool tricks you can do for those that have Arc access. As far as removing those redundant features in the attribute table for the depth area shapefiles, that's a similar process for QGIS or any other software program. It's just need to figure out which ones are representing that 1 foot interval and remove all the others, and then you should get it to display correctly, and it'll be a usable file at that point. So yeah, that's all I got on shapefile exports.
Hey, one question, Ian. Could you possibly really quickly again show how to delete the overlapping fields to produce the correct contours? Just one more time.
Yeah, no problem. So it's in the attribute table. Actually, I need to, I'll need to start over here. Let me just extract that again. I've got a fresh copy of the depth area shapefile. So in the attribute table, add field. Name it anything you want. I'm just going to call it difference because I'm calculating difference. Save the field. And then using calculate field, calculate the difference between max elevation and min elevation. So max elevation minus min elevation. And it will show you the difference between top end and the lower end of that depth range. And we want just these rows that represent 1 foot. Again, these are displayed in meters. So that's why you see 0.3048. That's the same as 1 foot. So then you can switch the selection and delete everything that does not represent a 1 foot interval in the layer. And then save that. And then yeah, that's the way you do that.
Thank you.
Is that better? Okay. All right. That's all I've got for that.
All right. Do we have any last minute questions? I know we're a couple minutes over here.
Can we ask them out loud?
Yeah. Go ahead, Kevin.
Ian, can like we've always been going through the old process of recreating the heat maps, the vegetation heat maps through the grid data, and we have a layer color file. Can we use that color layer file to apply the color scheme to these the shapefile export, or do we have to go through using that color column within the attribute table? Oh, can't hear you.
Sorry, I was muted. I believe what you're talking about is actually a raster symbol, raster symbology layer. So that would not be able to be applied to a vector vector shapefile. It would only rasters. One thing that I wanted to highlight too is so I used all these color codes to symbolize, but say you wanted to highlight some of the shallow areas of a water body, you can actually just go ahead and Google search the hex value for red, for example, and just plug that right into the depth range from 0 to 1 or 0 to 2 and automatically change those colors that way as well. Or if you wanted to highlight an area, like a deeper area in the water body, you could select those areas and plug in new color code values to highlight some different parts of the lake.
Yeah, I mean, that's a good point, right? So those are all hex values, and let's just say you have it in RGB and there's certain RGB colors that you want. I mean, you could probably throw it in ChatGPT and say, give me hex values. You could probably then change whatever level you want to those hex values, add that into the layer, and get it to display whatever color you want.
And another question, I know there was like a similar question about uploading polygons. Do you expect for the transect tool to upload like your own like border shape files or things like that? I know we have discussed that before, right? Or will it just use whatever border that BioBase uses for like a lake border?
Yes, right now what we're going to be releasing is it will use our shapefile boundaries to create those transects. And then you also put in an area of interest of kind of what part of the water body. Yeah, we'll have to talk about an improvement maybe down the road for including custom shapefiles. I did put in the chat something that is very high on our future development roadmap is to allow the uploading of polygons, pre-existing polygons, to your BioBase map. As of right now, it's just you can just create your own, and so you'd have to recreate one if you had that was a historical polygon, but soon you'll have the capabilities of uploading other polygons.
And sorry, Ray, I had one other question about the Polygon tool. So I've only used it a little bit, and how do you, or what's the best way to like refresh your Polygon? Because I had like drawn a polygon and then it processed and it gave me all the statistics, but then I wanted to change the boundary of that polygon, and I assume that did not just automatically then refresh the statistics along with that. Do you have to basically like delete it?
No.
Oh, it does. Okay.
No,
okay.
It does. So if you use the edit feature, there's the edit tool now up there. And you can, when you change that, share my screen here. Take a look real quick. So what we're talking about here is polygons. There's this edit tool here. So this allow you to edit the polygon, and then what it does, it will recalculate all the statistics and you'll get updated statistics.